look at the Pythagorean theorem today. Okay, Pythagorean theorem. So first thing I want to do is label parts of a right triangle. So in a right triangle, you have one 90-degree angle. We usually label that with that box in that corner there. Okay, that is a 90-degree angle. Across from that 90-degree angle, so across to the other side, that is your hypotenuse. Okay, that is your hypotenuse. The other two sides, the ones that make up that 90-degree angle, we call those legs. Okay, so this is a leg, and this is a leg. Okay, looking at the other triangle here, I'm going to label this angle as the 90-degree angle. Again, we use that box. Across from that, so to the other side, again, is your hypotenuse. And then the other two sides that make up that 90-degree angle, again, we call legs. Okay, so next we're going to write a definition of a right triangle.
It's 90 degrees.
One angle is 90 degrees.
It's 90.
So it is a triangle.
Wow, no way.
With exactly one right angle. And yes, that right angle has to be 90 degrees. So we are looking at the Pythagorean theorem today and using that Pythagorean theorem to find side lengths of a triangle. Okay, so definition for our Pythagorean theorem. In a right triangle, okay, so you do need to have a right triangle for this to work. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Okay, in symbols, that is a squared plus b squared equals c squared. Okay, where c is your hypotenuse. Okay, so c has to be your hypotenuse. It is the longest side of your right triangle. Okay, or we could write it as c squared is equal to a squared plus b squared. Okay, so if you want to write down the hypotenuse first, you can. So you can see that in the triangle over here. This lowercase c value is opposite that 90-degree angle. That is the hypotenuse. The other two values, a and b, are the legs of your right triangle. Okay, and that doesn't matter the order in this equation. So you can flip-flop a and b however you need to. So we're going to do some examples using this equation here. And we're going to solve for x. Okay, so letter A here. First thing I always do is locate my hypotenuse in my right triangle. Okay, it is opposite your 90-degree angle. So across from. Okay, since that is the hypotenuse, that is C in your equation. The other two sides are your legs. You can label whichever you want A and whichever you want B. Okay, so I'm going to label this one A and this one B. Okay, then all I have to do is plug it into my formula above here. Okay, so A would be 6, and that's squared, so we have 6 squared, plus our B value I labeled as 15. that's 15 squared. That's equal to our c value squared. Our c value is x. Okay, so you will need a calculator. So if you have a calculator, take it out.
Mine is in my pocket.
Okay. If you need to borrow one, I do have calculators. I do not have enough for everybody though. Okay, so you will need to find a calculator if you don't already have one. So from here, I'm just going to square each of these. So 6 squared is 36. 15 squared is 225. Still equal to x squared.
Would equal 264.
Okay, add those together, I get 261. Now to get x by itself, I do need to take the square root of both sides. Okay, so since I have an x squared value, to get x by itself, I'm going to take the square root of both sides. So in my calculator, I can type in the square root of 261. And you will get a decimal. Okay, so you get about 16.2. Okay, 16.16 or 15 something.
Do you just want us to round then?
Yep, you can just round. Okay, questions on how I did letter A in that first example? Feeling good?
Mm-hmm.
Yeah? All right. Then letter B, I'm going to do the same process. So first I locate that 90-degree angle. Across from it, thank you. Across from that angle is the hypotenuse. Your hypotenuse is always your C value. Then the other two sides are your legs. Those are your A and B values. Again, it doesn't matter which one is which. For us, I'm going to label X as A and 9 as B. Okay, from here, I can just plug it into our formula right here. So A first, that is X, and that is squared, plus our B value is 9 squared. And that's equal to our C value, which is 11, and that is also squared. Okay, again, I can square both of my numbers. So I have x squared plus 81 equals 121. Okay, you want to subtract 81 from both sides of your equation. So we have x squared is equal to 40. Now again, I want x by itself, so I am going to take the square root of both sides. Tell me if I'm going too fast. Okay, and that's what you would want to plug into your calculator, square root of 40. And I got about 6.3. For those of you who have a calculator, make sure you can get that. Questions?
This is easier than what we've done so far.
Okay. All right. So next, we're going to look at Pythagorean triples. So those are three non-zero whole numbers such that a squared plus b squared equals c squared. So this is where if you plug these numbers into this formula, you will get a whole number answer. Okay, so you can actually take the square root of that number. Okay, our examples here are 3, 4, and 5. 5, 12, 13, 8, 15, 17, and 7, 24, 25. Those are not the only Pythagorean triples. However, we can create more Pythagorean triples using these ones. So what I can do is I can multiply each of these numbers by 2. Okay, so 3 times 2 is 6. 4 times 2 is 8. And 5 times 2 is 10. Now the biggest number in each of these is your hypotenuse. Okay, so if you want to check to make sure it works, you would have 6 squared plus 8 squared, and that should equal 10 squared. Okay, so if I have 6 squared, that's 36, plus 8 squared is 64, equals 100. Does 36 plus 64 equal 100?
Yeah.
Yes. Okay, so that is a Pythagorean triple. So I'm going to do the same thing, but I'm going to multiply each of these numbers by 3 now. Okay, so 3 times 3 is 9. 4 times 3 is 12. And 5 times 3 is 15. So again, if you needed to check, 9 squared plus 12 squared should equal 15 squared. Okay, that is a Pythagorean triple. So we can use our reduced forms here to make more Pythagorean triples. So our formula for this Pythagorean triple, I would take 3 times any number, 4 times any number, and 5 times any number, and I will get another Pythagorean triple. Okay, we're going to do the same thing for each of the next triples. Okay, so 5, 12, and 13. I'm going to multiply each number by 2, multiply each number by 3, and then state the rule at the bottom. Okay, so 5 times 2 is 10. 12 times 2 is 24. And 13 times 2 is 26. So again, I just created another Pythagorean triple. Okay, same thing with the 3's here. So 5 times 3 is 15. 12 times 3 is 36. And 13 times 3 is 39. So again, our rule at the bottom, I can take 5 times any number, I can take 12 times any number, and 13 times any number to create another Pythagorean triple. So I could honestly multiply each of these numbers by 20, okay? And that would be another Pythagorean triple, where the Pythagorean theorem will spit out a whole number answer. Does that make sense? Are we confused at all? No? Alright, I want you to do the same thing for the last 2 Pythagorean triples. Those of you who would like to borrow a calculator, you can. You need to let me know, and you need to return it at the end of class, if that's the case.
I'm already done. Just comment math, you know. That was easy. That's mental math.
Okay.
That's why I like triangles best, because it's all you have to do is find the point in the triangle and go from there, you know? You already have your equation.
We do a lot with triangles. Oh, I'm sorry, I didn't know you had triangles. All right, those of you who are done filling in this chart, make sure your numbers line up with mine. Okay, again, that first row, I just multiplied the triple by 2. The second, well, middle-ish, third row, whatever you want to call it, I multiplied all of those by 3. And then the last row is the rule for each of those triples. Okay, so you can multiply those three numbers by any number, as long as it's the same number, to get another Pythagorean triple. All right, are there any questions about your triples?
Can we do home?
Not quite yet. There's the back page yet. It'll be super fun.
This is probably where all fun is gonna go. Heck.
Super fun. All right, so C and D, these two triangles are Pythagorean triples. Okay, these are Pythagorean triples. So if you know it's a Pythagorean triple, you can either look at your chart to try and find the last side, or we can reduce it to see what original triple it was, and then multiply back in, or you can still use the Pythagorean theorem to solve for that side. Okay, so I want you guys to practice the Pythagorean theorem a little bit more. So that's the a squared plus b squared equals c squared formula. So I want you guys to do these two problems right here using that formula to find that x value. Okay, find that x value. That way if you have questions, I can help you out right now, right away. So your button, you want to type in second, and then this x squared right above it, and then you can type in your number.
Isn't it like doing this?
When you're squaring it, yes.
Yeah.
Yes.
Okay. Well,
If anybody needs help with their calculator, let me know so I can tell you where the buttons are. Anybody else need help with their calculator locating the square button, locating the square root button?
I'll Domino's treat yeah. What? So far for you.
Play across the road.
Yep.
I'm waiting for that. I don't no, we're good. Let's see. So, yeah. Oh, let's see. Am I correct?
I hate raising my hand because one circulation.
Actually, excuse me.
Yes. Another zero there.
My
And
bad.
then you'll have it right.
Screw everybody, please.
So for your square root button,
What time is your game?
Was it this button?
we have to press second,
Oh.
and then
We leave here. Yeah.
anybody else need help with their calculator, help with the problem?
Hey, it's whole number.
If you want to try them, you can. And if you get the right answer, I'll give you your homework right away.
I got the right answer.
Good.
6? Yeah. We could all get
Hi, Nick.
No.
How's it going? Do I need to yell it?
You might as well get another argument. Anyways, what?
If you didn't do that second triangle yet, make sure you're doing the second triangle as well.
What, Preston?
Yeah.
No,
I did not tell him. Ashley? How do you know?
Again, if you haven't done letter D, make sure you do letter D as well.
Why does it keep saying answer? I don't want answer.
There you do.
Like A-N-S and then like I press for.
You're pressing the wrong square. Say you're pressing this one, you see that little X there?
Yeah.
Oh yeah. I think pressing the right one.
Oh. It just proves my stupidity.
No.
That's it. I
Hey, did you finish? What did you get for answers? Yep. What did you get?
Alright, I'm gonna start going through these. So letter C I have set up. Okay, letter C I have set up. So I have 48 squared plus 20 squared equals x squared. Okay, X is the hypotenuse because it's opposite that 90-degree angle. So it is your C value. Okay, so you should have gotten X is equal to 52. Did everybody not get 52? For letter C. Should have 52 for letter C. You should get a whole number for both of these because they are Pythagorean triples. Questions on how I got 52? All right, letter D then. Again, I want to locate my hypotenuse first before I start plugging numbers into the Pythagorean theorem. Your hypotenuse is across from that 90-degree angle. That is your C value in that formula. The other two sides are A and B. Again, that doesn't matter which order, okay? I could have flip-flopped A and B. So here, I would have x squared is equal, not equal, x squared plus 14 squared is equal to 50 squared. Okay. 14 squared is 196. Yes? Yes. 50 squared is 2,500. Okay, then to solve for x, I want to subtract 196 from that 2,500. to get 2,304. And then you want to take the square root of both sides. Okay, and we should have gotten our x value to be 48. Yes?
Yep.
Questions?
Draw a sketch.
All right. Then, letter E. We have one where we want to draw a sketch. Okay, so Lucy is locked out of the house. The only open window is on the second floor, which is 12 feet above the ground. To avoid some bushes, she places a ladder 5 feet from the house. Will a ladder that is 15 feet be long enough to get into the window? So we want to kind of draw a picture of what is going on. Okay, so we have our window, right? It's on the second story of that house. Okay, so we have the house and the ground. The window, it says, is 12 feet above the ground. So where should I put the 12 feet?
On the near the window.
Near the window along this wall, right? Okay, so this is 12 feet. Now she's placing a ladder at an angle, right? So here's her ladder. Okay, I'm kind of drawing a ladder
A
here.
15 feet ladder would be able to make that, yeah.
Okay, so here's my ladder.
How do you?
She's placing it 5 feet away from the house to avoid a bush, right? What?
Wouldn't that ladder be a bit short though to the window?
We're going to figure it out.
It is, it would be.
We're going to figure it out. No, we're going to figure it out. So she's placing the ladder 5 feet from the house. Okay, so that 5 feet is this length right here. Now it's saying that the ladder is 15 feet long. We want to see how long that actually has to be to make it to the window, to see if 15 feet is long enough. Okay, so we don't know if that 15 feet will be long enough or not. So off to the side here, next we want to use our Pythagorean theorem because the house and the ground make a 90-degree angle. Okay, so we can use the Pythagorean theorem to see how long that ladder actually has to be. What's our C value? What's our C value in this? Well, 15, right? But I'm going to label it as X in the Pythagorean theorem just so we can see the minimum length that it has to be. Okay, so that means the other two sides are A and B. So I can plug in 5 and 12 for A and B. And then I want to see what the minimum length that ladder has to be using the Pythagorean theorem. Okay, so 5 squared is 25. 12 squared is 144. Add those together, I get 169.
Noise.
Take the square root of both sides. And you should get 13. So that ladder has to be a minimum of 13 feet long. So is our ladder long enough to reach that window?
Nah.
Yes.
It's a ruler away from the big.
So I would write yes, a 15-foot ladder is long enough. Okay, 15-foot ladder is long enough. Questions on how I did letter E? No? Are we good? Do we understand the Pythagorean theorem? Yes? Okay, then I'll skip the last one. If you want to